Hello again. So we learned what happens when you take a linear transformation on the random variable on the variance. So then, okay, it's okay. So we learned two things. Addition has no effect on variability, on variance, but multiplication does change the variance. But the way it changes the variance is not desirable because when you multiply a, the variance is multiplied by a squared. So it's very inconvenient. Think about this. The reason is obvious. It's easy to understand why it happens. When you multiply a constant to all the outcomes, the deviations are inflated by a. The deviations are increasing at the same rate, but when you square them, the square deviations are multiplied by a squared. This is the source of the problem. So because you have to square them, that's the step where the variance becomes a little bit awkward. So at the end, the variance is inflated by a squared. I don't like it's very inconvenient because, for example, think about this. Your data is in, say, in dollars, but we would like to adjust inflation, for example. So then you have to divide the data by price index, which is a multiplication. Then the variance changes more than you your price index. So that means the unit is not preserved. The unit is not consistent. The unit of the variance is not consistent with your data. When you multiply 2, variance increases by 4. So you cannot match the unit. So to resolve this problem, we devise a new measure of variability which has a consistent unit with the data. That's the standard deviation. Its definition is quite simple. The standard deviation is simply the square root of the variance. That's it. So simply we did not like the square, so at the end we take square back by taking the square root. So this is the definition. It also measures the variability and is denoted by standard deviation, STD, of a random variable, or simply sigma or S. If you remember, variance was denoted by sigma squared or S squared. But now we thus because without square it means standard deviation. So standard deviation is the most commonly used measure of variability. So it's consistent that this unit consistency is a very nice property, and how do we? It's easy to understand. It's a square root of variance. So let's think about how the standard deviation changes in our previous example. In the previous example, as I said, standard deviation is just the square root of variance. So you have 12, which is square root of 144, and 12, and here 120. So square root of 14,400 equals 120. Excuse me. So what you see here is these two are the same because addition does not change the variability, but there is a 10 times, it increases by 10 times, which is exactly what we wanted because we multiply 10 from x to z. So from x to z, standard deviation is also multiplied by 10, exactly what we wanted, which uh, the variance did not have. So this is why we define standard deviation. In sum, then we may put additional formula under these two. So expectation like behaves really well. It preserves the linear relationship, and variance has some problems. Two problems: addition disappears and multiplication squared. So this was typically a problem. So we made up a new measure, which is the standard deviation, and now at least it preserves multiplication, even though it does not preserve addition. Addition disappears, but the multiplication is preserved in the same way. Same logic holds here. Adding a constant does not change the distance, so it's a parallel shift. So uh, standard deviation or variance are not affected, but multiplication affects the distance. So it changes, multiplication changes those two, but standard deviation preserves the same unit. So it proportionally change it is changed proportional to the multiplication. Okay, this was how we define standard deviation. Then how do we calculate the standard deviation? It's simply same as the variance. It's simply the way you calculate the standard deviation is first calculate the variance and then take its square root. That's it. So basically the same process you have done for the variance is how you calculate the standard deviation. So all the same theories for the variance holds here. Like you have to distinguish sample standard deviation and the population standard deviation. They have different formulas, and in particular, the denominator, whether you use n or n minus 1 in the denominator, is the major difference. Refer to the variance slide, variance formulas. Also, you have to calculate square root deviations and multiply probability when you have probability distribution table. Just add one last step after calculating the variance. That is just taking a square root. To better understand what happens in the standard deviation, just try this. The simplest possible example. You have three observations. Suppose that these three are your data, minus 3, 0, 3, and calculate the standard deviation of these numbers. Just try it, and I will stop the video here, and I'm going to continue from here next in the next video. And in between them, please try this, calculate the standard deviation by yourself. It should be easy enough. So try it and see you in the next video. Thank you.